that what I'm starting with?
I'm sorry, no. 17.
17.
Can you also do 30, 31 and 33?
17. 17 says tangent inverse of the square root of 3 over 3. So what are we doing with tangent inverse? What are we looking for?
X over y.
Yes, we're looking for x over y, but we're saying this is looking for the angle, where x over y equals the square root of 3 over 3. And without a calculator, that means it has to be something we know in the unit circle, which the only things we know in the unit circle are things that are either square root of 3 over 2 1/2, square root of 2 over square root of 2 over 2, or switch backwards 1/2 square root of 3 over 2. Like these are the three places that we know. Which of the two of those include a square root of 3? First one, last one. So we just have to figure out which one of these guys, if you arrange it as x over y equals this. So you may not have memorized that. I haven't memorized that. Because if I memorized it, I would get it confused because I already have to think about this. Like I memorized the square root of, the pi over 3 one is this, and then I know the other one's the opposite. Like there's a limit to how much my brain can memorize. So if I just take one, Peyton said use this one. Is that what you said use? Then we just try it. It's either going to be 1/2 over the square root of 3 over 2 or square root of 3 over 2 over 1/2. Like those are the only two options that have the square root of 3 in it.
If that's not tangent, wouldn't it be y over x?
Oh, y over x. Sorry. I totally went with what y'all said. Tangent inverse means where, but tangent is y over x. Like tangent is y over x.
This is co-tangent x over y.
Yes. So it doesn't mean the inverse switches it. It means we're looking for the opposite. It's still tangent goes with y over x. Glad y'all were keeping up. Sarah set me straight. Okay, so Peyton said try. So I'm doing y over x equals, the y here is 1/2. The x here is the square root of 3 over 2. And then to simplify it, we multiply by 2 over the square root of 3, and we get 1 over the square root of 3. And then you're like, but wait, that's not what it says. But then if you rationalize it, you get the square root of 3 over 3, and you're like, whoopee! So then you get a skittle. Skittle for saying the answer? Today there are Skittles. I'm sorry you missed it. Parker, Skittle for asking the question? Okay, please don't dump them all over the floor. They're continuous on the couch there. So what are we doing now? We're saying tangent inverse of this. There you go. Good job. 1/2 over the square root of 3 over 2 equals 5 or 6. Because when we went to pi over 6 and we tried this, we got the same answer. So tangent inverse gives a radian address, which is the same thing as an angle. Boom, 17. So your answer is going to have a pi over 6 in it, pi over 4, pi over 2, pi over something to get answers here. So 17. Then am I skipping to 23?
Yes, it's just the tangent ones that confuse me.
They are tangent. They are confusing. The idea being that you're going to have to do this fancy fraction stuff because you haven't memorized tangent. Because we don't use it as often as we use sine and cosine. Like we need to understand tangent, and sometimes we have to figure it out, but it's not as often used as sine or cosine.
I'm sorry.
So 23 was a choice of problem from a lot of people. Let's go there. Y equals arc tangent of 0. Y equals arc tangent of 0. So that means the same as inverse.
Okay.
So we could have written tangent to the -1, and that would mean that you're finding the same thing. So the answer here is an angle again.
0. Oh,
So
0. Oh, it's so easy.
Would you write 0 or 2 pi? 0. Which one would you prefer? Just write 0.
No.
So here's the thing. Where does tangent exist? On the board, I still have it. Where does tangent exist? Is it here?
Yeah.
Okay, is
Yes.
2 pi in this space?
Yes.
2 pi?
Well, I mean, technically, but if you don't go all the way around, right? Oh, it's 0.
It's 0. So if you put arctangent in a calculator, oh here. Oh, okay, sorry.
What was that?
That was one of those.
Was that ugly button?
I believe that if you put in a calculator arctangent of 0, you're not going to get 2 pi. The calculator can only give one answer. So while tangent is 0 at 0, arctangent, and it repeats, we had to limit tangent. We can't use, remember tangent looks like this over and over again. We had to say, well, that doesn't have an inverse. Only this one has an inverse. And this one is not at 2 pi. Is that coming together? Coming together?
I had a great one.
23. Okay, so then next was 31. 31 says tangent inverse of 5. Tangent inverse of 5. So in 31, if you looked in the back of the book, this is Bob, back of the book, it says 31, 1.37, 1.3734. So that indicates it's a calculator problem where you go second tangent 5. So you had to put in a calculator.
That's it.
Yeah. The back of the book answer is this. We're going to need this in the next section when we come back from break. We're going to solve equations, so we need this stuff that we're doing now. So what does that mean on the unit circle? Where about is this angle? I'm telling you up here that this gives you an angle as an answer. Where is 1.3734? Okay, wait, so this is 0 and this is 3. So 1, 2, 3, well, 3 is not there. 3 is 3.14, like it's there. 1, 2, 3. Does that make sense?
Yeah.
So 1.3 is like here-ish. I mean, I don't know. I'm just guessing.
But
I have an idea about it because I know about pi and what pi equals.
But with tangent, how do you know where it goes? Because isn't it both x and y?
Okay, but this is the tangent part. This is the ratio of tangent is y over x.
Okay.
But what you get out is the angle. And the angle is just the angle in this circle, right? It's not related to sine or cosine. Yeah.
How many values of
I just really know 3.14.
pi? Okay.
Then does it go 1.5?
1.5.
Okay, that's all I know. Okay, good job. So 33 was the same. Use a calculator. Check. Then we went to 43. 43. Ooh, good one. 43. 43 says, and I have a similar one to that on the board. Ooh, I have the same one. Okay, so sine inverse of sine of 7 pi over 6. Yes?
They just cancel out, right?
Not quite. Wait. What?
I'd say is it only when sine's on the outside and sine inverse on the inside?
Okay, so do they cancel out? Like, how can you do this? Can you do the square root of -4 and get an answer you can see?
No.
No, because -4 isn't in the domain of the square root function. So is 7 pi over 6 in the domain of sine inverse? No, because sine is like tangent, it's only over here. Because this covers all the positive values of sine, this covers all the negative values of sine. So 7 pi over 6, he's over here. He's not in, so we actually have to figure this out. So we do this part first. What's the sine value of 7 pi over 6, which is this angle in the unit circle? The sine value, yeah, so -1/2. So now we have sine inverse, and this part is -1/2. And now when we evaluate this, it doesn't have anything to do with 7 pi over 6. We can think about it in the domain for sine inverse, and the value that's at negative 1/2 is here, and that point would be the square root of 3 over 2 negative 1/2, which is going to be negative pi over 6. This is the trickiest kind because this 7 pi over 6 is not in the domain for sine inverse. If they're in the domain, they just cancel. But if they're not in the domain, they can't cancel. Does that make sense? It's harder, but yeah. 43. What else was on our list? 45. 5 pi over 4. So same deal. 45 says tangent inverse of tangent of, yeah. So tangent has the same half circle answer possibility section. So 5 pi over 4 is also in the third quadrant. The 4s are my favorite because 4s have the same x and y value, right? So this is going to be positive or negative 1. Tangent is y over x. So it's going to be negative square root of 2 over 2 over negative square root of 2 over 2. Positive. Because 5 pi over 4 is 1, 2, 3, 4, 5. It's right here where they're both negative. So the tiny unit circle helps you with those fine details. Because you just have, those details are important. And then this becomes positive 1. So we figure that out. Good for us. And now we eat Skittles. And now we find tangent inverse of 1. So now we're here. I don't know. Who needs one? Ben, Skittles?
Sure.
All right. So where's now tangent inverse of 1? Because we have to deal with this. Where's positive 1 for tangent? Just 1? Just come get some. Oh, that's weird. Okay. What quadrant is tangent inverse of positive 1?
First quadrant.
First quadrant, right here. And this is pi over 4. So pi over 4.
Hold on. Okay, 1. How do you know that that's in the first quadrant? Can we go over that? I'm confused.
Okay, so tangent here, this is positive, positive, like the cosine values are positive.
Oh, I'm so sorry. Never mind. I got it now.
But that's okay. If it didn't come to you, we need to talk over it. Yes.
So I plugged 45 into a calculator just to check it because I was unsure of my answer. And so it came about as an error. So would that be due to because
You did it just like this?
Mhm.
So tangent inverse of tangent of 5 pi divided by 4 parentheses. Whoops, not there. Parentheses, parentheses. And then pi divided by 4.
Okay.
Now, if you did tangent inverse of 5 pi over 4, that'd be a problem.
I may have done that.
Okay, 43. Oh, I already took
45.
that off.
Can we do 47?
That was 45.
Yeah, we did 45.
Okay, so 47, this is just you have to figure it out because 47 doesn't have you undoing anything. 47 says sine inverse of cosine of 3 pi over 2. So we need to actually go to 3 pi over 2 on our unit circle. Where's that?
That's the bottom.
Bottom, right here. So this point is 0, negative 1. So we evaluate things in parentheses first. What's the cosine value of 0, negative 1?
0.
0. So we replace cosine of 3 pi over 2 with 0, and then we write sine inverse. And now our question is, where, sine inverse is an angle, where is sine 0? Where is sine 0? 0 or pi, but pi is not in the domain. Nothing over here is in the domain for sine.
Sine
Right. So this is either 0 or pi.
Yeah.
But it has to be the 0 one. Like, there aren't two answers. That's why this is the inverse. There's only one answer. So sine of 0 is 0. Because here it is. The y value is 0. So sine inverse of 0 equals 0. Yay? Okay. It is confusing. We just have to keep practicing it. 47. 51. We were going to 51? Here we go. Ooh, cosine of 5. 51. This is a good one. For those of you at home, please note a star goes here. Tangent inverse of cosine of 5. Where is cosine 5?
Nowhere.
Nowhere, because cosine looks like this. And the highest value it has is 1. It doesn't ever go to 5. So this does not exist. There's no solution. Whatever you answer that's something like
What
this
does that say?
does not exist.
D-N.
Can you do 49 next?
We have to go backwards now? Okay. 49. Arcsine of tangent of 1. And if you don't like arcsine, you can totally write sine inverse of tangent of 1. What?
Wait, 51?
In the,
This is 49.
no, I know, but
That's what I did
in
with
the
the
cloud,
thing. I
what
just
is
skipped.
what does it say?
This
Yeah.
does not exist.
Wait.
Or you could write no solution.
I write
Max,
today.
Max, Max. Oh yes, what? Go.
50, it doesn't say 51 doesn't exist.
What does it say?
It says it's 0.2764.
51. Cosine of 5.
Cosine of 5.
Can I write
Cosine of 5.
applicable?
Oh, I'm dumb.
Is it because you can
Oh, cosine inverse doesn't exist. Okay, so I'm a dummy. That's why there's a star there. Cosine inverse of 5. Let's try that. I was so focused on the 5. Cosine inverse. Hold on, I gotta make sense out of what I just said. Oh, there I go. Okay, I'm a dummy. Cosine doesn't exist. I was looking for the angle. Okay, so go, Max. 5.
Yeah, cosine 5.
So 51, is that got decimals? Yeah. So we're not going to have calculators. So you wouldn't have this calculator, no. So what did I do wrong? This is not an angle. What does it mean to be cosine of 5? Cosine of 5 means go, this is 2 pi. This is 6, so that's 1, 2, 3, 4, 5, 6. Okay, what did I do wrong? I did wrong because I was really focused on the opposite. Cosine of 5 means go to 5. 1, 2, 3, 4, 5, and pick the y value. And it has a y value. And that was done on my part. See, it's confusing. I just said that. There's recorded. There is an answer. So my cloud is bad. I know y'all wrote pretty calculator, pretty clouds, and there's not one. So, cosine of 5 is some value. This will be a calculator problem. I'm going to tell you cosine of things that are on the unit circle, like cosine of 0 or 1 or 1/2 or the square root of 3 over 2, things that are on the unit circle.
So how do we distinguish between like actually
Okay.
Going to the X point versus going to
Okay, so this is supposed to say where, this is what I wrote before, where is cosine equal to 5? Where is cosine equal to 5? What x value has, and by x value I mean radian, has, what do y'all need? What questions do you have? Because I'm trying really hard to undo my confusion from before. All right. So what x value or what radian is cosine equal to 5? Meaning on the unit circle, as you go around it, up here on the unit circle, the biggest value on the unit circle is 1 or -1. So cosine inverse is looking for these to be values on the unit circle. Whereas this is saying you could unroll your fruit roll up and it could be as long as you want. You could plug in anything you want. Like if you're riding a bicycle for 27 miles, you're going to go around and around. And this is a different time. Yeah, right. Okay, 49. 49 is what we're doing now? Okay, so tangent of 1. What is tangent of 1? This is another calculated problem? 49.
No. It's one of those weird ones. It's like, what? Pi over 3?
So tangent of 1.
But 49 is not.
Pi over 4.
49 is not the answer.
I know, I'm trying to go from like proving it to people. Tangent of 1 is 1.557. Sine inverse of 1.557. Okay, so if we check this out in our calculator, I can actually just go up to it, delete. I can take that and put it here. Sine inverse of this angle. And the calculator tells us this. Why is that true?
Because it's bigger than 1.
Does not exist.
So, right, sine, this says where is sine, which means the y value equal to 1.557, question mark.
Wait, why is tangent of 1 not the pi over 4 where it's...
Oh, we can't go to 1.5 because
So
y
this is the angle,
Yeah.
not the, this is saying that you go to 1 on the unit circle. So here's the difference. Tangent of pi over 4 means put the x and the y value from pi over 4 into your equation.
Okay.
So on the unit circle, pi over 4 is this guy, right?
Yes.
Okay, well, tangent of 1 means go to 1, which 1 is going to be here. This is 1 and this is pi over 4. Like this is the angle. This is how far. How is that 1? What does pi over 4 equal?
Square root of 2 over 2.
Hold on. Pi over 4 is a number. It's 3 divided by 4. It's about 3/4.
Okay.
So this equals 0.78.
Okay.
So your unit circle has, this would be 0.1, 0.2, 0.3, 0.4, and then we get to 0.78. And then we get to 1. Like there are all these angles that we don't use.
Okay.
We've called them pi over 4 because we divided it in according to radians because we have a unit circle with a 1 as a radius.
Yeah.
But it turns out that pi over 4 is approximately 0.78. So 1 is just a different angle. A different angle. And tangent of 1 is a different x and y value. Like they're just I don't know what they are. I could figure it out. Tangent of 1 equals sine of 1 over cosine of 1. Sine of 1, 841. Cosine of 1 is 0.54. So, Parker, here's exactly where 1 is. I go 0.54 on cosine. I go almost a half, a little bit more than a half. And then I go up 0.8. This is where the angle equals 1 is.
But why is only this equation like that? Why are none of the other ones like that?
Because they didn't give us something we know in the unit circle. They gave us 1. That's why it's a calculator problem. We haven't memorized every single point. There are an infinite number of points in the unit circle. And I don't know all of them. I only know pi over 6, pi over 4, pi over 3, pi over 2. Like, I know the pi ones. but I don't know. I don't know where my plate went. I don't know the angle at 1. I don't know the angle at 2. I don't know the angle at 3 or 4 or 5 or 6. I can count any way I want. We've chosen to use the unit circle because see how these are not symmetrical?
Yeah.
That's hard. We've chosen to make it symmetrical where we have the pi over 3s, pi over 4s. So this would be a calculator problem.
Okay.
I'm going to move on just for time's sake.
Okay.
I don't know where the time is. Does anybody know what time we get out of here?
Is the
Oh, I have it right here. I lied.
is the new schedule
1:25. Oh, it's the same. Okay.
What?
We have 5 minutes.
We have 5 minutes.
Can we do 70 and 71, please?
Yep. Okay, let's skip to 70. 70 says Kim is watching a space shuttle launch. So we've got a person here, and they're watching a rocket lift off like this. Okay, and they're 2 miles away. 2 miles away. How about that?
That's good.
The rest of the question says, find the angle of elevation to the shuttle for each of the following heights. So very quickly, we have it it's up here, 0.5 high. Does that make sense?
Mm-hmm.
So what's the angle of elevation really from their eyeballs over? So theoretically, we went straight up. So now we're looking at the angle from the person to the shuttle is opposite over adjacent. So we go, okay, the tangent of the angle equals what?
0.5 over 2.
Yes. 0.5 over 2. So setting up the problem for this, once you see it, you're like, oh yeah, I see now how they're looking at it, and that makes sense. Now, how does inverses play into this? Do we know anything that looks like this? Like in our unit circle, what we were just talking about with Parker, do we know what 1/2 divided by 2 is, besides it being 1/4? Tangent equals 1/4. That one we don't know. It's not one we know. It doesn't have a square root of 2 or a square root of 3 in it. It's not 1 or 0, and so I don't know what it is. So this is a call for the calculator, and like I said, I'm not giving you calculator problems, but what happens is tangent inverse on both sides undoes the tangent. It's just like taking the square root of a square. We undo it. So tangent inverse undoes this tangent, and now theta is free. We free theta, and now we take the calculator and we go, hey calculator, could you tell me what second tangent of 0.25 is? And it says the angle is 0.245. And then the rocket goes further up, and then it's 2 miles up. So it's 2 miles up, and now the ratio is 2 over 2. This would be tangent of theta equals 1. And we actually know that. What's that?
0.75.
Okay, but also we could have made this pi over 4. Because that one we know. That one we should know. Tangent of 1 you should know is pi over 4. And then we could do the third one, which was 2.8 miles. So in another few minutes, it's at seconds. It's at 2.8 miles. And we just do a third one that says theta equals, or tangent theta equals 2.8 over 2. And we tangent inverse both sides. And we put in our calculator tangent inverse of 2.8 over 2. And let it tell us what the angle is. So we had to draw a picture. The next one, 71. This was 70. The picture's kind of weird to see, but Jesse's drawing in a race. He's sitting in a boat, or she's sitting. These are both androgynous names, so I don't know. But there's a paddle that's 7 feet long, and then the angle from whether they hold their paddle out or closer to the boat changes. And so this is the distance from the boat. It's either 2 feet, or it could be at 3 feet, or they could hold the paddle more farther out, and it would be at 5 feet. So 2, 3, or 5. So looking at the simplest first equation, 7 feet and 2, what relationship does 7 and 2 have? Which value with this being theta?
2 over 7.
So sine is 2 over 7. So we're going to do sine of theta equals 2 over 7. Sine inverse. That looks like theta equals, and then the calculator, sine inverse of 2 over 7. Or in a non-calculator problem, you just leave it here. And you say, well, I can't find it because I don't know 2 over 7. That's not on my unit circle. So this is why we need the inverse functions, is so we know how to put it in our calculator. Okay, so there you go.
Thank you.